want to calculate the moment of the 10 Newton force about point P. So according to the diagram. So if you observe, according to the diagram, the force is at a distance of 12 meters from the point P, but that is not the exact distance. That is not the perpendicular distance. So to get the perpendicular distance, let's extend the force. If we extend the force, so the distance from this point to P, that is the perpendicular distance. So this is the perpendicular distance. So that is the distance we are going to be using, because moment is equal to product of force and perpendicular distance. And that distance is the same as distance from here to here. So we can decide to just find this distance. So if we draw this line, we have 90 degrees here. So calculating that distance as x, this will now form a right-angled triangle. So let's redraw the right-angled triangle. This is the 12 centimeter. This is the distance x. The angle is 30 degrees. So according to trigonometry, if in a right angle triangle you are having the adjacent and the hypotenuse, this is the adjacent and this is the hypotenuse. Hypotenuse is the longest side, so you are going to be using cosine. So you use cos 30. Cos 30 is equal to adjacent x all over hypotenuse 12. So x is equal to 12 cos 30. So cos 30 is root 3 over 2. That is equal to 12 times root 3 over 2. And that gives 6 root 3. 6 root 3. And now the moment is equal to force times perpendicular distance. So the perpendicular distance is the x we have calculated, so which gives us force of 10 Newton times 6 root 3. So, and that gives 60 root 3. So 60 root 3, that is the answer. So remember, we use cos here. Remember, we used cos because this is adjacent and this is hypotenuse. If we are having this, if this is what we want, it's going to be sine, that is opposite over hypotenuse. So, and this 60 root 3 is the same thing as 103.9, which is approximately 104. 104 Newton meter.